Welcome to the Code of Entry podcast, where we cloud the issues with facts and help you upskill to stay on the digital edge. Here's your host, Greg, with the latest.
Hey team, Greg here with another Code of Entry podcast, this time joined by Keri Fischer again. Insert applause. Okay, so welcome back.
Thanks.
It's been 1 or 2 episodes since you were here last time. I think you're going to just start hanging out, so welcome to the show.
Thanks.
She's a woman of many words. Today, what we're going to talk about are kind of data pipelines. And I say data pipelines, we're just going to talk about how information flows through a system and how you get data in and use it. And we're not going to be super technical. That way you can, remember it and use it and apply it. This isn't a stump the chump kind of thing with a whole bunch of terms. We'll have some stuff, but just trying to make it so that you intuitively can understand what happens in a system from problem definition to using the data for whatever your use case is. Because at the end of the day, that's the intent. Colloquially, and Keri and I were on this data team for years, dealing with, just over 1 million events per second. Trillions of events over our time. In that, it was gather, prepare, store, and use. Okay. Should be pretty easy to remember. You want to gather data. You want to prepare it for use. Then you need to store it so you can use it. And then ultimately use it for whatever you're trying to do. Now, we're going to gloss over one thing that's very important, maybe do a separate podcast on it, but that's the problem definition side. So first and foremost, you shouldn't be gathering data if you don't have any type of use for it. What is your mission space? What decision are you trying to inform or affect? What information does that require? Then what's the question you're trying to answer? Once that, you'll know what data to collect. I think there's one side, there's one big exception, and that's going to be compliance. There is some data that just legally you have to have, or you have to store based off your industry. So you got this area of what question are you trying to answer? And then legally, what are you supposed to? Either law or organizational rules that require you to hold different types of data. We're going to gloss over that problem definition side because I like to hear myself talk, as Keri pointed out right before we started recording. And let's just stick to the data system, the things themselves. But Keri, anything that you'd like to add to that?
Sometimes looking at the use case or what problem you're trying to solve, data may not exist either. So you may get into a gather stage where there is none and you have to generate it, and or however you're going to go about doing it, whether it's by surveys or crowdsourcing, whatever it might be. But you might need to gather the data like organically yourself to answer the question.
Yeah, that's true. And I think we can hit that when we focus on gather in a second. And we'll probably start with that because that's a great point. If we dive in specifically to gather, there's a few ways that you can get the information. Let's assume that it does exist for a minute. So you can do batch transfers. So you gather some data, you send it as a group. Then you gather some more, you send it as a group, and you can process it as a group. You can stream it. So near real-time use cases, think video production. Something like, hey, Fox Sports doesn't need a production truck at every NFL game. They can have a single production place that the video is getting streamed back to and done centrally. Make a better use of your talent, your time, travel money. There are a lot of use cases for streaming.
Facebook
Live, if we were streaming this video. And then there's micro batching. So I'm a big fan of micro batching over streaming in general. If you're not doing like a live video use case, I think micro batching is the way to go. Instead of making a big batch and sending something once every 12 hours, I'm going to send it once every 2 minutes. That kind of relies a little bit on having a high volume of information because you still don't want to be processing a whole bunch of little files, but you can gather them together to where they're a decent size and you send them. That way you're not waiting forever. I use the analogy of an old VCR. If you're listening, you know what a VCR is. Shout out. And with a VCR, what was happening is you couldn't watch something until it was done recording. So it was basically a batch job. I took and I set my VCR on channel 3, and I could watch channel 3, or I could wait until the game was over and play it back and then have my TV back, but I was locked on that channel. So that it happens to explain two different use cases. The one is the batch of, hey, I've got to wait until it's done and then I can play it back. Okay, great. The other is that's actually how the streaming ends up working, because you have to have specific machines dedicated to catching the stream. And then when the stream is done, you can really make use of the stream as a kind of a corpus of information. Now, you can have some certain streaming analytics and stuff going, right? But to compare the stream to other information and get the whole goodness out of it, you have to wait till the stream's done. And that resource, that VCR, that TV, is locked to processing that one job. So if you want to do a lot of parallelization in your system and prioritizing what resources do what, and you don't want to have specialty nodes all the time, streaming ends up being a high price for you. So that batch, what it gives you a chance to do is, hey, this podcast is done. How long did it take you to download this podcast? Seconds. You didn't have to dedicate a resource to listen for it for however many minutes it goes, and then make the file available to you to do other stuff. This, sorry to say it, this wasn't the priority thing in your life, this podcast, so you're able to wait until it was done, and then it transferred in a very small fraction of the time, and you had the information. It can inform anything that you want. Say you're going to give us 5 stars, thanks again. It could inform that decision, but you didn't need to stream it to your computer and then watch it back.
You could just play it from Alexa.
You can also just say, hey, Alexa, play the Code of Entry podcast, and we'll see if the one in my room right now is going to start playing it in the background. That'd be super great, because she's always listening. And you don't have to dedicate those resources. And then it goes back to the micro batches. What the micro batches allows you to do is get the information in a timely manner when you need it for not real time, but near real time. You can have something show up every minute in tip and queue. And a lot of industries and a lot of use cases, a minute is good enough, right? If you're doing fraud detection on credit cards, yeah, you want to be faster. You know, if you're looking at an entire enterprise network and you're trying to take threat intelligence and compare it and look at it against different sources, you're going to have to microbatch. You're not going to get that in real time. And just a shout out there for kind of batching, streaming, microbatching. I've got some technologies written down associated with those and how you can do it. But the other thing is, how do you gather when you don't have the data? And Keri brought it up. I'll toss it to her first and then give you my take on it.
Most of it's been on more research development. So if there is a data set, you can make your own data, synthetic data, if you want to use different types of software to make that, especially when it comes down to cyber data. It's a possibility, right? For other data that you're trying to maybe gather, you might be able to partner with other survey holders like Canopy and all those other ones, and then they can submit your questions out, and then they can get some of that information back. Similar to like a census. We have census data now, but it is like manually provided, maybe more automated now that we have computers, but still it relies on someone providing that input. And so if you can find your target audience of what you're trying to get access to for that data, you'll have a better way of figuring out how to get access to that target audience. So maybe your surveys are really going to be on Instagram in comparison to other places. You have to figure out what the demographic is and try to target how they utilize technology to get access to the data they have in a legal way.
Yeah. And I think it's really the first problem in saying, hey, I want to do data analytics, I want to do analysis. The first step is you have to gather data. But a lot of times you're not instrumented to have the information that you want to have. So if you're not instrumented, that kind of goes back to this problem definition thing. There's going to have to be a decision about which data sources you need to answer the question, which ones you're instrumented for, and how you're going to start. Because sometimes you're going to take data that's better than nothing, but it's not perfect because you have access to it, or because it's small enough that you can collect. If I can go back to like network data, so working at like a DoD scale, it'd be great to have Bro or now Zeek for the entire enterprise, but it's cost prohibitive, right?
Yeah.
So what you do is you collect that, you store it somewhere that's not as readily accessible, that's a little bit cheaper, and you use other data sources to stitch together and do that first evaluation of, hey, do I need to dig into that more expensive, larger data set? But I think it's the other thing too of, hey, if you might have to build a data platform. You might have to go buy a data platform, because a lot of folks are like, let's do data science. Better yet, we're going to do AI. Okay, let's assume we're not talking generative AI for a minute. Then that means I need data. Okay, we have no data. Okay, great. We need a data platform. Great, we have a data platform. Let's do analytics. Do we start sending any of the data? Do we have the data over the right amount of time? Can we identify trends, seasonality, anything? So it takes time sometime. I was alluding that Keri and I are working together for years. I mean, built a data system and it took 3 or 4 years to have enough data, enough business cases, enough users to be effective. And it's had a huge return on investment, but it took a lot of time, right? So, hey, you're going to be a data scientist. Awesome. I have no data. Build a platform, get the data, build a few applications that can show that the data is valuable, then put data science tools on it so people can rapidly turn on those. But it's a long process. So in this gather realm, going back before I get way down, my list here, I put a couple technologies that you can use to move and gather data. One of those being Beats from Elasticsearch. You can also you have Elastic, Logstash, and Kibana in the rest of the Elk stack, and you can use Logstash to move files, but generally to collect them from like endpoints and stuff, Beats is good, and it's open source and free. You got things like Kafka. Kafka is a little bit more heavyweight. It's going to be you streaming those logs from one place to another. You're going to need servers or whatever, but it's the best in class technology. You can use it for inter and intra communication, so inside your data system or from data system to data system. One caution there is if you have really latent links that you want to attach across, it has a hard time with highly latent links. I think in the commercial world, most folks won't have to worry about it. But if you're on a network that's made of tin cans and string like we used to be, then it might be a problem. Next one is the Amazon CLI, AWS CLI. We were using AWS Cloud, and if you wanted to get files to S3, that lightweight CLI would hash the files, send the files, automatically take larger batches to micro batches, check the packets on each side, check the hashes on each side, get it where you need to go, and give you your receipt. You couldn't get much better, and it was very light script. And then on the other side, there's just doing like an SCP, a secure copy, SFTP kind of thing. And a lot of times, though, that'll require, if you're taking it into the cloud, regardless of the provider, you'll have to create like a bastion node to make the connection with and then send the data through. But just some different ways to gather the data. And I missed all of Keri's points there about, hey, sometimes the data is a survey. Sometimes it's more qualitative data or categorical data, not necessarily event logs or something.
Yeah.
Or
if you're making the investment on that platform and aggregating the data, you have apps that are going to help analyze it. You can also have apps that are just going to generate that data. A user inputted information can give more attributes that way as well.
Yeah, and I think another way that I completely forgot about until we're sitting here talking is just using an API. API accessibility is huge. And in our world, it wasn't. We had a few APIs that we would hit. Yeah. But again, to segregate your data system from other systems, you don't necessarily want a direct API call. We can talk about that conspiracy theorist point of view some other time, but architected system doesn't do direct API calls. So again, you would have some bastion nodes, have them do an API call, then drop the data to some intermediate point that you trusted, and then pull the data from there instead of going out across the wire on the internet. But yeah, API is a good way to take data, send data. It gets you into this almost death by microservices land. So microservices, quick summary, small APIs. And so if you got a system that has a lot of microservices, great. It was well architected. Everybody knows what they do. They're great. Awesome. Good for you. As soon as you start having microservices communicating with microservices in other places and all these bespoke connections that can't be used by other things, you just end up unraveling the organization of your system. You're not going to be able to trace things. So you start making security holes then, and making it hard for app developers to know where to come to get data in your ecosystem. So there's that pet rock. So we'll go from gather to preparing data. And I'll let Keri talk to you about preparing data as our resident data scientist here. Keri.
So some of the tools you mentioned for gathering data, there's a lot of tools that are available that are gather and prepare, basically, because combine it into one. So being able to access it with whatever software they want to start moving it, and then they want to start to somehow extract it, transform it, whatever they want to do with it, there's a lot of businesses that will actually provide that all in one. And that comes with a couple different pieces, right, from the prepare side. I was always taught in school that preparing the data is the hardest part. 60% of your job. The other percentages are easy. And then rolling into the last job, The gathering was the hardest part of the data, not preparing it, making the transforms and making the normalization and writing it to disk and having the enrichments associated with it. That was the easy part, which was crazy to say when they just honed it in your head. That's the hardest part. We're talking about larger scales of data when we're talking about wherever these different endpoints are at for gathering it. But the preparing side, they have you all in on the data scientist side, and then you're supposed to partner in a team effort. So if you have some good data engineers that can help you prepare it, you have to have some sort of domain knowledge of that. So wherever you're getting the data from and preparing it, you'll have to know what some of the attributes are, maybe what some of the terminology is, a lexicon, because you can determine that there's things that are malicious and things that are benign, especially in the cyber domain. And if you have no domain knowledge, you'll just be like, oh, 70% of my data set's benign. This is great. I've identified something that's awesome. Like normal traffic. Thank you very much.
Yeah. No, that's an administrator login versus a regular user login or something. Yeah. Yeah, and I think along those lines of kind of the gather, prepare, data science conundrum, exactly right. Like I showed up to the same place. Hey, you're going to be the data scientist that's going to make all this happen. Oh, sweet. Where's the data? Well, we don't have it yet, but I've got nothing to prepare. And then by the time we had prepared it all, we had worked with other folks. We had come up with our standardizations, how we were going to normalize it. Transforming was easy. So what you end up finding is people that have been doing this at a real production scale, say one, are pretty limited. Unpopular opinion again. But two, a lot of folks that have been admiring these problems or that are focusing on the governance and how we should do it aren't doing it and don't realize how easy it is to prepare data. The technologies are there. You don't have to wait for a consensus on how you're going to normalize it. You can just start, by the way. And if it changes, you can update it. That's why we recommend several different things when we're talking about how to set up a data system, but not the point of this one. But you have the information. Great. Normalizing it is easy. Use NiFi and set up a NiFi template. Put your file in there. Let it go. Once you make one transform for one file type, you really just need to create a markup file to show the mappings. That's not hard. Or there's any number of commercial products now that you should point your data to and have it help you. Or AWS Glue. You say, hey, I'm putting all this data in S3. Glue crawler, go make me a data catalog. You can't make it easier than that. Yeah, preparing the data is not that hard. It's one of my pet peeves. Thanks for pressing the button. That you have a lot of people talking about, oh, we need to do data munging and data wrangling. Those terms drive me crazy. We need to professionalize a little bit. Those terms were great when we first started talking about data in the late 2000s like this, but now they're not the words, right? So you need to be talking about transformation of data, normalization of data, sanitization of data. Yeah. Anything else on prepare?
You have different levels of talent that can help prepare the data. So if you have someone that's used to using Microsoft tools, say Excel, and we want to move into Power BI, and we're talking about smaller data sets, there's a group of folks that are really experts in that, because what we're talking about is learning more tools than the tools that maybe the average user isn't using, right? So the willingness to learn the tools, and then what does that talent look like to transform the data and then load it, or to load it then transform it? Which way do you want to do it? And there's different expertise that can help that, but I think it's an evaluation of whatever your talent pool looks like, whatever your use case is, matching it up with those types of tools. So you talked about all the different tools available. My mom wouldn't be able to do any of that stuff. She'd need to pay somebody.
Yeah, and I think on the tool side too, and I had this notion for a while that if you were using Excel, you weren't doing data science. And I think I've fallen back off that position over the years, because I think what it was is I was just in this land where we had really big data. And I was just kind of, you're not really doing data science. You are, it's just a different specialty, right? You can sling some VBA and use Excel to do a lot of great things if you have less than the million rows or whatever the limit is today for Excel. It's going to be adequate. Go from Excel to using R or Power BI, but something like R. Then you start graduating to larger data sets, and you can use your Jupyter Hub or your R to do pretty large data sets. Then start using Python, PySpark, Scala. Yeah, so there's options there, but I guess the other thing in the prepare, he brought up ELT and ETL. So you can extract, load, then transform, and extract, transform, then load. if you need to do something where you have to look at all of your data to confirm or deny and all of your data is going to be used, ETL all day. You need to pay the tax up front once and transform your data and then make it so that it can be run across analytics, anything else. If the vast majority of your data is going to be stored and never used in your use case, then yeah, ELT is fine. You don't need to transform it unless you're going to use it. But if you start talking about machine learning and AI, the whole idea there is that you're going to give the data to something to process to help you find what's important. You don't want to assume what features matter. You want to analyze what features matter. We can't analyze the features unless you brought them in, which means that you need to transform them. If you're going to transform every time that you do analysis, you're going to transform the same data potentially a million times versus just doing it once and storing it. So I think, in my opinion, right, the solution there is ETL. And when you ETL, then before you do the ETL, you store a raw copy so that you can always go back to whatever the original state is, put it in cold storage, secure it. It's there for law enforcement purposes or wherever, or you update the transformation in your parser. But then you don't pay that tax over and over again. Now, if that's not your use case, hey, absolutely bring it in and just transform what you need. But again, that can be expensive if you need to do it over and over again.
I like to sprinkle in enrichment into that process as well.
Yes.
Because the native data, and when you do load it, that's great. But you could have extra attributes that can already be predefined and put onto the extra data set. So you can have 4 columns that turn into 20 columns just by what you've already done enrichment on. And that can actually help provide downstream everything that you would need from the data analysis perspective or the automation or the machine learning modeling and or getting into the AI part.
Yeah, like I know all of these are MasterCard transactions. I know all these are Visa transactions. I know based off this IP address, it was this section of the company. I know based off this IP, it was on this threat indicator list, and I could say that this one is identified as bad. You can do all these things. You can do a lot more. I can say, hey, I had an analytic running. I had a streaming analytic on this because we were doing financial fraud, and I was able to flag this as fraud. And when we ingested it, mark it as fraud so then it could be followed up. And you could update your models and your training. There's a lot you can do with enrichment that, again, you can't enrich. Maybe not again, but you can't enrich if you're doing ELT because you didn't transform everything, right? So you can lose a lot of context by waiting to do that. But there's some systems that live by it. Just, again, depends on the use case. Yeah.
And sometimes those enrichments come from whoever you're doing your presentation to. They ask you a question. They'd be like, how many X did Y? And you have no idea that part because you didn't do that enrichment up front.
Yeah.
And you can automate it.
You could have a list of, hey, all my Fortify scanners have this IP address, and now I can mark them all as Fortify when I ingest the information. No, it wasn't identified that way on the network. All my domain controllers, my security centers, my admin usernames have this convention. Let's mark them up. My host names have this convention. Let me tell you where they are in the building. And you can have a lot more useful information in your data lake there.
Yeah. Or just people, where they're from, where they're born, voting, all that stuff. Non-cyber use cases. All right. So that's prepare in general. So again, transforming data, normalizing data, sanitizing data. Maybe changing formats so that they're universal, matching up timestamps, everything to UTC because you could have users in different time zones. So there's no limit there. It's your imagination, but you want to try to do it the same across your data sets. Don't be afraid of starting and changing your mind later because then you're going to be paralyzed and never do it. You're not going to get started. So just get started. And once you change your convention, just go apply it. Re-ingest the data, have it overwrite what originally got ingested. You'll be fine. It won't cost you much. Okay. Now storing data. And this is where I start talking about if you're in a data system, you've got this land north of an API and below an API. There are a lot of people that care about data storage that shouldn't care about data storage. So if you're an application developer for my system, I don't want you to care about the data storage. In your app, great, absolutely. But I want the storage to be south of some API that you hit to get access to information. I want the data engineers to decide, hey, this information would be great in Postgres. It would be great in a graph database like Neo4j. It would be great in Mongo. Or, hey, we're going to use Databricks. I know that's not necessarily a data store, right? But I'm going to use that product to worry about my data storage. Whether it's structured,
unstructured. Who cares? I want you to hit an API and ask for the information and then get it. And then inside your application, let's assume we're using Kubernetes, inside your namespace, you can store it in another database. That's fine. But if you always worry about the data store from a non-data engineer, you can do suboptimal things. And there's a lot of folks that are like, well, I'm a graph expert. It all needs to be in a graph database. Okay, maybe you can use a Postgres adjacency matrix, right? If it's one time ever and it's not that much information, I'm gonna throw it out there. Not that much information is in like the hundreds of terabytes range. So most people don't have a real use case where they just need a graph database. If we're talking social media, okay, I got you. Different use case. Most use cases out there, you don't need just graph. But you also, unless you're the solutions architect or the data engineer, you also don't need to care. We're in a land of containers now where I can add containerized solutions in my app space or down in my system layer south of that API. Your data at enterprise scale needs to be designed by a real data engineer to figure out what kind of data store it goes in. And, oh, by the way, what kind of data store it's secured in. So that's why I try to draw that line between that API, because at that API, I let my users, whether they're developer users, data science users, clicky red button users, affectionately, those users should all not get access to anything database level access, because then you can ensure that it's secure. You can be like, hey, you have these permissions, these authorizations, you're allowed to see what you're allowed to see. Whether I need column level security, row level security, cell level security, it depends on the data set, depends on the user, depends on the use case, and you can really limit that once you start using the API level access, because again, I let an app only pull what the app has permissions to pull, and I enforce the security at the layer in my system so I have more trust in what applications get used to and whatnot. Now, I talk about the kind of these storage structures just for whatever it's worth. You want a document database? Sure, pull Elastic. For most people, it's open source. There are some things in the license. If you're going to recompile it from code and sell it and stuff, you might have to pay for a license. If you're going to be doing a graph, hey, there's a lot of free ones out there and it's changing all the time. I'll tell you, Neo4j is a good supported one, but there's a lot of options there. Google it. There's some newer Apache projects. That's probably where you go. And then relational Postgres is probably the dominating choice. And I use MySQL a lot, but I think Postgres has dominated that solution these days. Lastly, I'll put S3 has come a long way towards being a data store. People are like, oh, it's just a file folder. Not anymore. So being able to dump all of your data into S3 and apply QuickSight or even SageMaker to it, S3 has become more and more performant as a data store. As an aside, we might have dropped a region of S3 for data system in my past. So we tried to use S3 before it was ready. So we did make that change eventually, but just a funny story that, yeah, if you were in the West Coast and you didn't have S3 a few years ago, my bad. Okay.
Sorry.
Yeah.
Sorry.
Hashtag sorry, we tried.
So you said a lot of folks not to worry about storage, right? So like you have the data analysts, data scientists, they need to make friends with who so that they can understand the storage. Who is that? Are we talking about engineer? You said data engineers, but like data architects, system engineers, who do they partner with because they're part of that team structure? So yes, pulling the API, but if they don't understand like samples of the data, like who do they go make friends with?
Yeah, there's going to be a few people in that realm. You're going to have whoever your cloud solutions architect is, your system administrator, your cloud engineers. You're going to have somebody over the system too. Like this whole thing needs a pretty technical PM. And so as you're having these scrums, these stand-ups, I think what you can't be afraid of is if you try to ask for something from the API and it comes back in a format that doesn't work for you, or it doesn't come back because you don't have the right permissions, it becomes a discussion that just has to be evolving. Just don't make the assumption that data needs to go somewhere specifically, and don't make the assumption that the data is not there if you ask and you don't get a return. You have to ask the question. Because we experience that a lot where people just assume you don't have that data. Actually, we have that data. You just don't have the authorization for that data. And maybe you should have the authorization for that data. We had a 1 million person enterprise, right? Like we couldn't keep track of every person and their use case. Open lines of communication, ask the question. Maybe we have the data, you just don't have the authorizations because we didn't realize that you were a specialist in niche area number 973. Guess what? We'll give you that authorization. And now there's a whole bunch of data. Because I remember specifically, we started masking HTTP details. And somebody was just like, but I really need the HTTP details, and y'all don't have that level of reporting because it's too much information. I was like, actually, we have the HTTP details, but we found a system that was reporting all of this HIPAA information in the clear. I'll say in the clear. I'll explain in a second, but all this HIPAA information, and we were giving a lot of people access to HTTP details, and we had to mask it because we didn't want to say, hey, a 9-digit number, we're just going to ignore that record. Because now an adversary could start putting in a 9-digit number into everything they were trying to do, and we would drop the record. So we needed, and it might be a social security number. So we needed the information. We didn't need everybody in the enterprise to see it without the need to know. Now I say in the clear, so the sensor that was picking this data up over the network had the decryption key to view encrypted traffic in a different way. So it might have been secure, but because we were pulling it and it was decrypted so we could see everything that was going on, we created this area where we needed to protect the information. And so it was just like, hey, we're going to mask that. Now, if you had the need to know in your job role, absolutely we'll give it to you. But don't make the assumption that it's not there. Have the conversation instead of making an assumption.
On the periphery, I found an increasing trend of cataloging data. And that goes into a little bit of hopefully having a catalog available, and it is sanitized, and at least masking some of that information, and at least know what fields are available and what's been collected or acquired, and that can be available based off those permissions. Whether it's on the gather side and you need to go find it in a catalog, or you want to prepare it and pull it from the catalog, but storing it, yeah, that helps.
Yeah, and I think I was the anti-governance and catalog person for a long time because we were just trying to make it happen. And if I waited for everything to be perfect, we weren't going to do anything. But now there's so many tools and so many automations that can help you create the catalog, figure out what fields are there. I think it's gotten a lot easier. We originally tried to crowdsource it, and then everybody was too busy to contribute, and it didn't happen. So we ended up with the catalog of what the fields were, but no explanation of what the fields were. And then some people would go in and they would add fields that didn't make sense. And yeah, so I think we're in a much better place with that now, thanks to some technology enhancements.
Well, and there was deliberate investment too from the team members to do that.
Yeah. Get started, gather, prepare, store. Once you have data stored, you can start getting into some of those governance things a little bit deeper, right? Because it's there for people to use, which is the next step. But if you worry too much about the governance before you get to the store phase, you're just going to be admiring the problem for the next few years, and you're not going to get started.
So there's use cases of, I can't store the data unless I understand what the catalog is that matches for that data. But I can't tell you what should go into the catalog because I can't even open it up because you're not allowing me to store it. So it's a chicken egg thing.
Right? Yeah, but just because you store it doesn't mean you have to enable access to all users, but you need to at least start storing it so you can get your subject matter experts visibility to it.
Yes.
Yeah. Okay, so we're in the last topic here, using the data, which is the most fun one, and hopefully you can get there. Using data, we'll go through a list first, and it's, hey, you can do analytics on the data, you can do applications based on the data, and I'll say there's two different things. I'll go back to the API so you can access the data to use it or have it consumed by your applications. You can have containerized applications or containerized databases or containerized analytics you've bought from other people that are now accessing your API. So you can use it with more advanced things that, who knows, maybe it's black box because you don't own the algorithm or whatever it is, but containers have opened up a lot. Visualizations is another way that you can use it because visualizations are not necessarily analytics or applications. Notebooks, and I say apps because I've replaced applications in my mind with just, hey, I'm going to explain it as apps because we don't want these monolithic applications that have their one way to talk to the system. We want apps, and I know they're technically the same thing, but different explanation. So I'm going to step back one to notebooks because I think what ends up happening is the first step is you're going to make some analytics, and they're not going to resonate with your users. They might resonate with your decision maker, but you're going to have a hard time with community adoption with just some analytics. It's going to be too hard and people aren't going to use them, speaking from experience. Then you're going to make like an application or two that's going to help somebody do their job. It's going to have a cool interface, hopefully, and some blinky green and red lights. And if it's red, hey, you need to click this button. If it's green, you're good. Don't worry about it. And you're going to win over some people, but then people are going to be like, oh, your system only does X because that's what that app does. It has nothing to do with system limitations. It's just what they see. But you asked for that app. Oh, but that's all you do. I don't think so. So then that goes into like notebooks. And I think what starts flipping it is, hey, so we had this idea we were going to be data scientists with no data and no platform.
Science all of the data all of the time.
Yeah, we're going to science all of the data. A funny thing, we had a lot of data somewhere, but we weren't storing it. So we had to start gathering it and preparing it and storing it. Finally using it, and we go through this thing where, all right, we made cool analytics. Okay, not accessible enough to win over the user population. A couple of cool applications. Sweet. We won over a couple of people, and a lot of people were like, oh, that's not my job. Your system doesn't do what I need it to do. Okay, great. Finally, notebooks, because now your data scientists can get in. They can make some simple analytics and visualizations, give it to a user, and they'd be like, I didn't know you could do that. Then as you do that, you can find some that are going to be used once and throw them away. That's great. That's a perfect use of a notebook. We're not going to make that into an app. Or something somebody's doing once a day. And we're going to be like, hey, guess what? That's going to become an app. For now, this will be the tourniquet, and we'll make an application based off that. But you can do so many prototypes and figure out what sticks instead of having to pay or millions of dollars or spend years making this full-featured app that you hope will work. So I think really the transformative time is when you can get to being able to have notebooks on your data, because you can provide rapid prototyping, figure out what works by showing people, and then making a more robust application centered around that use case. So in this use realm, containers have had a big impact. Just Kubernetes has been transformational in allowing this to maybe increase access to the data, but also allow you to put data stores north of the API much easier.
Yeah.
And then with kind of this analytics and application, just there's a lot of definitions. So we're being pretty informal about this, right? Gather, prepare, store, use. So the difference between analytics and applications, because we used to use analytics for everything. So in my mind, the difference between analytics and applications is that analytics are some module of code. It can be simple math. It can be something super complex. Don't care if it's code, a search put into a window, enter, then it's analytics. An application is one or more analytics. So something that's doing data kung fu that has a custom user interface. That's it. So if we're going to say it's an application or an app, it's an analytic with a custom UI. It could be 20 analytics with a custom UI, but that's that helpful discernment for the conversation on what you're doing. So you have these super kung fu searches that you're doing in your search interface. You're the best Splunk pipe command person ever. That's great until you put a custom UI on top of that, right? You haven't gotten to the level that you're going to be able to propagate an effect across the enterprise or like really drive business decisions on a routine basis because it's just not accessible enough. Okay.
I think the end part really from the uses, you're trying to tell a story. You got ones and zeros coming through. You're trying to analyze it, whether it's automated somehow, you're running code, analytics in the background, chaining them together, making it complex. In the end, it's got to tell some sort of story that either can be briefed to, live at face value, have a paper written about it, but there's usually some human it just depends on where the human is at in the gather, prepare, store, and use, right? If you can get so many extra folks over into the use category, then they can use the rest of the talent that they have from that domain expertise and iterate into making more changes to the notebooks, more advancements. And then if they get to that point, they can start changing the codes for the application as well. So those smaller features come through. But from like point A all the way to the end, you're gathering the data to solve answer whatever the problem was. And if you're getting to the presentation mode and it doesn't help answer the problem nearly at face value, something's broken in between, right?
Yeah, and one of the things that got me when we first started being able to support the notebooks was there are folks that were able to do some pretty powerful analytics in the notebooks, but they really failed at the visualizations. And that's because generally, and maybe in overgeneralizations, but generally to data scientists, the number is what matters, right? The answer is what matters. Okay, that p-value is X. Well, that's great. You're going to go to most leaders and they're going to be like, the what?
Correct.
So what you really need to be able to say is, okay, in this visualization, this plant is underperforming. I can show you because here's our 50 plants, and these are all green because the rating is over 9,000, and this one, the rating is 72. It's how do you visualize the data so that it's intuitive to draw the decision out without any words? Because if user training is required, it's going to be an uphill battle to communicate your narrative. So just think about, hey, is this selling my story without me having to be in the room to explain to somebody what it means?
Although you do like to be in a room to explain what it means.
I do like to be in the room to explain what it means. You're right. So that's really a high level data systems, data pipelines discussion on gather, prepare, store, and use what you need to consider for data ecosystem, taking a data-centric approach. We have a lens personally for a lot of DoD stuff, but those 4 things, we didn't specify necessarily, hey, I need to worry about logging cyber events, or I need to be worried about collecting financial information or health information. Those 4 things are always going to be the same. You need to gather the data, you need to prepare it so it's useful, then you need to store it. Again, with the store thing, hey, even if you don't transform it, if you get a chance to collect data and you think it's not important, please at least just put it in cold storage. Because you never know, you might get the opportunity to run some advanced algorithms or say, hey, I'm going to put this all in a principal component analysis or K nearest neighbors to tell me which features I should be using. And you find out some feature you never knew was important, but you have the data to do that, right? Because that's the whole thing of using the machine is we're not making assumptions from a human side, or we're talking about logs or text information, reports, extracting text from reports, image, doing computer vision knowledge of image and having the objects all detected in an image so you can do it. Talking about imagery for an MRI or an X-ray, right? All of this information could potentially be important. It could help with a research project. It help somebody else. And it's less than cents on the dollar to put terabytes of information into cold storage. So just, hey, if you get a chance to access it, get it to the cloud somewhere, get it in cold storage, and then you've got it. And then if you end up in like cybersecurity land, there's a lot of stuff going on in the cybersecurity world. We don't necessarily know it's important until there's a 0 day. Hey, guess what? We didn't know that was bad. And unless we have the information to look, it's a much better place to know that you can heat it up and access it in a couple hours than you don't have it at all and you're just out of luck.
We'll never have it again once it's gone.
Yeah, so you can't go back in time unless you stored it at some point. Awesome. Keri, any final words?
I think we talked about large volumes in some of the use cases, and then we talked about things that at small volumes, like lessons learned that you get from this portion of gathering and preparing and storing and from large volumes. Not all the lessons learned we're talking about apply to everything that's small. You can make a lot of different changes or have smaller issues that pop up, and you can definitely fix them in whether you're coding or whatever it might be. So your small use case of 100 megabytes of stuff, and then scaling it out, we're giving like an overarching recommendation on how to gather, prepare, use, and store. But knowing that as long as you're trying, just start by doing. If you don't start by doing and you just continue to admire the problem, you're not going to make headway. So at least sling some code, try it a little bit. You come to a point in time where you need help, then you reach out to your different talent that you have that you know about.
Yeah, or us.
Just start. Or us. But yeah, that's also a valid reach out and ask us the questions, but just start. Even if it's just starting to have the conversation, it's at least a starting point in comparison to just a problem that will always continue to be a problem and then no one is looking to try to solve that problem. Those are my
Awesome.
words.
Thanks for everybody for listening. We'll do a follow-up episode about some data terminology as I started on my soapbox of not using data munging
Wrangling.
or data wrangling as terms anymore. But hey, just one last wrap up. Gather, prepare, store, use. Preface that with a little bit of problem definition of, hey, what am I trying to answer? And you're on the right path to being able to take a data-driven approach regardless of your industry. So,
Teamwork makes the dream work. You need a team to do it.
yes.
Find a team.
One person can do it all. They're not going to have any job satisfaction. You're not going to retain them.
Correct.
At a minimum, what you're looking at is starting this maybe with a data scientist as your first investment to help you do some of the problem definition. Then you're looking at you need a real data engineer. And before you go to the use phase, you have to include a domain expert. So I think a minimum of a team of 3, kind of data scientist, data engineer, domain expert.
If you can pair up your domain expert to have some sort of analysis skills, that's usually comes inherent with the domain, but I just don't want to presume. That's helpful.
Yeah, it's hard to find the unicorn that can do it all. I'm sitting next to one of them, but that's not normal. Yeah, appreciate everybody listening. Until next time, keep hustling.
Thanks for listening. Find us on social media at Code of Entry and online at codeofentry.com. Check back for new episodes or join the team by signing up for notifications. Until next time, keep hustling.